So, what is all this leading to? Welcome back, by the way. All of this, first the evidence that it looks like plates were at one point connected. Now that we know what's driving the movement, the different types of movement, what did all this kind of accumulate to? Well, it accumulated to something called the plate tectonic theory. Plate tectonic theory. Be careful with that word, theory. Let's talk about that word, theory. In everyday common language, the word theory is misused. That theory, how we use it in normal language, I think Batman is better than Superman. Oh, that's just your theory. The way we use that word, oh, that's just your opinion. That's just your guess. That's a very low level of knowing something, a guess or an opinion that's not backed by evidence, information. Oh, that's just your theory. I'm better than you. That's just your theory. That's your guess. That's your phony baloney idea. Here's the thing. That's not what theory means. That's not what theory means in science at all. Not even close. It's the exact opposite. Theory in science is the highest level of knowing. This term theory doesn't get thrown out a lot. Plate tectonic theory. Theory of evolution, the Big Bang theory, the theory of gravity, gravitational theory. So let's break that down. Let's break down that word before you think it means something else. So again, this is the highest level of knowing science. A theory is testable, it's repeatable, it's never been proven false. You hear me? You've never been proven false, and it's widely accepted by a broader community. That's the highest level of knowing in science. So the theory of evolution, never been proven false. But, well, I don't believe it. Well, okay, whatever. That's a different ballgame, whatever. It's just never been proven false. But the beauty with science, we don't use the word true because never been proven false. Well, maybe there's some evidence that comes along that changes the Big Bang theory or aspects of the theory of evolution or plate tectonic theory. And if it did, well, then we would change to make it better. None of that has. None of that has changed. So, the word theory is the highest level of knowing. Be careful with that word, especially in class. So, plate tectonic theory, highest level of knowing, testable, repeatable, never been proven false, widely accepted. So, basically it wraps up that large pieces of Earth's crust are called tectonic plates. They are in motion due to that underlying mantle convection from leftover heat. There are 7 major tectonic plates and many smaller plates and even many, many more microplates. Major plates include typically both a part of continent and a part of an ocean basin, so continental crust and oceanic crust. Continuing on, again, what's wrapped up in this plate tectonic theory is processes associated with the creation, movement, and destruction of these plates, collectively known as plate tectonics. So it's not just the motion, but also the creation, the movement, the motion part, and destruction. That's what's all wrapped up in plate tectonic theory. It's responsible for plate tectonics in general. The movement of plates and the crashing and destruction of plates is responsible for several of the most devastating natural hazards, obviously including earthquakes and volcanoes. And we'll get more. These will be different units after this one that will deal with each of these things kind of differently. Earthquakes, volcanoes. Each new hazard will be a kind of a new unit. So, kind of, summing it up with the tectonic cycle, right? We got Earth's internal heat heating up the rock in the mantle, which is causing the material to move around. Some of it melts, not all of it. Remember, the mantle is mostly solid rock. There's little pockets of melted rock we call magma. More on that later unit. But that leads to volcanism. But also this movement of mantle material leads to seafloor spreading, divergent boundaries, creations of new ocean crust, which causes, if plates are moving apart in one area, that means they have to be crashing apart in the other area. Everything can't just move away from one another. So that causes subduction at convergent boundaries. Or some of that material, that rock material that gets subducted, melts back into the mantle, gets incorporated back into that mantle to become that hot Play-Doh rock stuff. Some of it goes directly to liquid form to form these small pockets of magma to create volcanoes, and that cycle happens all over again, all due to Earth's internal energy, trapped heat from formation and radioactive decay, causing mantle convection to move stuff around. This is where we're going. So these first few units that we'll discuss, we're going to live in this tectonic cycle. So here's a map of the world, broken up into some of the major and minor plates. So again, the North American plate, South American plate, Eurasian, Africa, Indo-Australian plate, sometimes considered one, maybe two. But there are minor plates, like the Juan de Fuca, again, the Caribbean plate, Cocos plate, and there's even micro plates, little pieces around the edges of some of these things. The Pacific plate is the largest plate, over 103 million square kilometers. That's a big one. North American plate second, Eurasian, Africa, Antarctica, Indo-Australian plate, if you consider them one, and the South American plate make up those 7 major ones, and then a bunch of minor ones as well. So again, the Pacific plate, it doesn't look like it, but it wraps around to the other side of the world. It's underneath the Pacific Ocean, which is the largest ocean. There's also a little bonus plate, the Juan de Fuca plate. So it's on the smaller end of a minor getting into a micro plate. So it's one of the smallest tectonic plates. Again, it's technically not a minor, but a micro plate. But it may be one of the world's most notorious. You don't have to be big to cause a lot of hazard and destruction. It is part of the famous Ring of Fire, which is a zone responsible for volcanic activity, mountainous regions, and earthquake activity that surrounds the Pacific Ocean along the boundary of the Pacific plate. So here's the Juan de Fuca. It's converging with the North American plate. So there's a divergent boundary on the western edge, which is causing the eastern edge of the Juan de Fuca to crash into North America. Up here we have, obviously a little bit in Canada, but Washington State, Oregon, Northern California. And in these locations, known for earthquakes and volcanoes, large volcanoes, Mount St. Helens, Mount Rainier, any big mountain in Oregon and Washington for the most part. Those are all volcanic mountain ranges, the Cascade Mountain ranges. So it doesn't have to be big to cause a lot of, damage. It's small, but again, you have that subduction zone, that convergent boundary causing powerful earthquakes and volcanoes in this region of North America. Fun stuff. So I tell you what. That's the end. We'll expand more on earthquakes and volcanoes in later units, but again, this was just about Earth's internal energy, where it came from, what it does to the different layers, how mantle convection drives some processes on the surface, driving plate tectonics, different types of boundaries, different hazards associated with those different boundaries. Before we go, excuse me, remember that super secret code I gave you in the previous video? I want you to subtract 1 from it. So put that original super secret code into a calculator if you need some help, and then -1, hit equals. That's the actual answer for the super secret code. So you see it kind of split it up between two videos. Sometimes it do that. So make sure just paying attention to the videos, like obviously you are right now because you're hearing me. Pay attention, watch, listen. We will use this information in lecture, so make sure you're answering the question or questions provided. We'll discuss this material possibly in class. And until next time, see you then.